This talk in the Building Minds with Patterns series is about the observation pattern. We will briefly highlight the features of a generic cognitive architecture and discuss design patterns for cognitive systems. Then we will delve into the specifics of the observation pattern, and finally we will show how this pattern fits into some existing cognitive systems. What is a cognitive architecture? A cognitive architecture is a design for an artificial mind. It is realized in a diagram depicting the elements of the mind that the architects claim are necessary and sufficient to support thinking or cognition. But how do we build such a system in the first place? The answer is simple. We need to establish a list of requirements identifying what the artificial mind will do. Once these requirements are elicited, we can then design a cognitive architecture to fulfill the requirements. So at a very high level, some initial requirements could be that 1, we want an artificial mind to communicate with a device such as a car, a robot, a smartphone, or an avatar. And that device is situated in the real world or situated in a virtual world. 2, the device will send data. We can call this data observables from the world to the mind and receive commands from the mind. And we can call these commands actuations. 3, some components will think about the observables and infer new information about them. We will call these components coordinators. 4, we will need to have the system learn and improve its behavior over time. The system will therefore need to observe its own performance. We will call components that reflect upon the system's behavior reflection components. 5, we want the system to stay within its capacity for memory and performance and not get slower over time. So we need to periodically consolidate the information stored in the system, and therefore we need components for that. These 5 basic requirements can be supported in many different architectures. So we now present a generic cognitive architecture template. In essence, a cognitive architecture is a blueprint for an artificial mind. Here we see areas for observation, coordination, reflection, and consolidation, as well as the device situated in the world. In this template, we can see a device situated in a real or virtual world. And this device communicates with the cognitive system through observation components, which store input from the device into the system's memory. The observation components are also responsible for communicating with the device's actuators, which perform actions in the world. We also see there is a coordination components, which update the memory with new inferences. The reflection components are responsible for changing the overall behavior of the system. And finally, the consolidation components are responsible for ensuring that the memory does not exceed its available capacity. What are cognitive system design patterns? Isaiah Berlin once said, "To understand is to perceive patterns." In building an artificial mind, it's helpful to start somewhere and preferably not from scratch. There are a number of cognitive system design patterns which can be used to implement the required mind functionality. Mapping requirements to design patterns can assist in defining the overall mind architecture. Some design patterns are depicted below. Today's focus will be the observation pattern. What is the observation pattern? Observation is the process of receiving sensory input from the body. Jean Piaget identifies the process of observation as the assimilation of observables through the senses. In my understanding of Piaget, the word assimilation means formation or creation. So in my opinion, observation is the process of forming observables in memory using data coming from a remote or peripheral device. Forces for using this pattern include the need to store observables from a device in the memory of the system. In the observation pattern, observables are cached or persisted so that many components may act upon them. Sensory data sets, percepts and urges, collectively called observables, emanate from a device in the real world or in a virtual world. A perceiver component captures the observables. The perceiver module creates or updates the observables in memory. The memory holds the observables and any inferences which may result from the observables. This pattern is useful when there's a need to share observables with multiple modules or multiple components, or when a historical perceptual trace is required. What is a cognitive system? A cognitive system is a software and hardware implementation of a cognitive architecture. It is the instantiation of an artificial mind. There are a number of cognitive systems that have been researched extensively. Here is a chart of some cognitive systems and the design patterns they implement. Cognitive systems which have the observation design pattern are highlighted in the first column in yellow with a red outline on the cognitive system chart. In order for us to study cognitive systems, we have to align them so that their elements are comparable. The characteristics among cognitive systems that seem important are the ability to perceive information from a device, the ability to be reminded of prior events and situations, some sort of internal control or coordination among the elements of the cognitive system, the ability to plan sequences of actions, and the ability to execute actions. These general regions are depicted in the comparison template, and the cognitive systems we study will be laid out accordingly. From the 2004 paper, An Integrated Theory of the Mind, John Anderson and Associates discuss the Adaptive Control of Thought Rational, or ACTAR, cognitive system. We can see it has many correspondences to brain regions, as well as a few non-correspondences, such as the intentional module. Transforming this diagram into our comparison template, we can see that the observation pattern is highlighted by a perceiver element, which was called the visual module in the original diagram, and a memory element, which is called the visual buffer. The remaining elements in the regions for reminding, planning, and execution are clearly depicted. From the 2006 paper, A Gentle Introduction to SOAR by Lehman, Laird, and Rosenblum, we get a view of the SOAR cognitive system, with areas for perception, action, control, and memory. The observation pattern is highlighted with elements for the perceiver and memory in the transformed architecture. In our comparison template, we can see that the differences between the ACTAR and the SOAR system are that the SOAR cognitive system is much simpler with fewer internal elements. From the 2023 paper, Synergistic Integration of Large Language Models in Cognitive Architectures for Robust AI, an Exploratory Analysis by Oscar J. Romero and Associates, we see a micro-agency cognitive architecture with agents which leverage a global workspace to share information. The agents could be represented as rules in a rule-based system or as threads or processes. When we lay out the micro-agency system, we see the observation pattern elements of device, perceiver, and memory very clearly. Also from the 2023 paper, Synergistic Integration of Large Language Models in Cognitive Architectures for Robust AI by Romero and Associates, we see a neurosymbolic cognitive system which leverages a large language model as a connectionist subsystem. Transforming this cognitive system, we likewise see the observation pattern. We see the elements of perceiver and memory. So to recap, observation is the process of receiving sensory input from the body. As it pertains to artificial minds, observation is the process of forming observables in memory using data from a remote or peripheral device. Forces for using this pattern include the need to store observables from a device in the memory of a system. In the observation pattern, observables emanate from a device situated in a real world or a virtual world. A perceiver element creates or updates the observables in memory, and the memory is designed to hold the observables and inferences based on the observables. You can read more about this design pattern in the book Building Minds with Patterns, available on Amazon. If you found this information useful, please like the video and subscribe to this channel, and visit us on Patreon. Become a member so that we can bring you more helpful content. Find us on the web at Linktree, and we'll see you in the next video.